inverse trig is the first topic we're going to talk about in Unit 4. One thing we need to remember, okay, it says recall that a function has an inverse function if and only if it is 1 to 1. So I don't know if you remember that phrase or not, but 1 to 1 means that for every input, there is only one output. For every X, there is only one Y. Graphically, when you learned about inverses back in Algebra 2, or maybe in Algebra, I don't remember when you first learned about that, but a function has to pass the vertical line test, or an equation, a relation, whatever, has to pass the vertical line test to be a function. Okay, if your graph doesn't pass the vertical line test, it's not a function. Y'all remember that? Okay, so 1 to 1 means that it passes the vertical line test, essentially. Okay, something else you may recall about functions and inverses is that you switch X and Y to get an inverse function. So you could take all the coordinates of a function and you flip the X and Y, the input and output switch, and that would graph the inverse. Okay, so if we think about our trig the trig functions that we focused on the most were sine and cosine when we were graphing, right? Okay, and that was a wave, the sinusoid, the wave going up, down, up, down, up, down, right? If I switched all of the X and Y values of that, okay, if I reflected it across the line Y equals X, it would end up, it would be the wave, the same wave, but it would be going vertically like this. Okay, and that would continue forever. Okay, would this pass the vertical line test? Definitely not. Okay, we'd hit a lot of places, like infinitely many places. Okay, so the inverse of sine and cosine isn't a function unless we restrict to just a certain piece of that function. So we have to restrict. Now, when we were graphing sine and cosine, we would look at one cycle at a time. We would focus on one cycle. So for instance, from what was a maximum to another maximum, or a minimum to another minimum. Okay, that would be one cycle, because then the graph would start repeating itself, right? Okay, but I can't even look at just, if I looked at just one cycle, would that pass the vertical line test? Still wouldn't. Okay, so I'm still not even able to do one cycle. I've got to shorten it up even more. Okay, so to get a piece that would not repeat, a piece that would pass the vertical line test, I could only go like here to here, like from a maximum to a minimum, half a cycle. Y'all see that? So it's a half a cycle that would pass the vertical line test. Everybody with me still? So keeping that in mind, when we look down here at the sine graph, you can see they've restricted it to just half a cycle. And this half a cycle is the piece between negative pi halves to positive pi halves. Now, the reason that's the section that they're using is because if we think about this, think about your unit circle, okay? So 0, pi, and that's there all the way around to 2 pi, right? This is pi halves, and this is 3 pi halves. Do y'all remember all students take calculus? That's for where the trig functions are positive. If I think about this in terms of quadrants, sine is positive in 1 and 2, right? So the exact same sine values that I get in quadrant 1, I hit the exact same values in quadrant 2, don't I? So that means they're repeating themselves. So that wouldn't be a function. So I can't use quadrant 2 because it's repeated values from quadrant 1. Graphically, this is quadrant 1 from 0 to pi halves. It's this little piece. That's quadrant 1. And you can see quadrant 2 here. Yeah, when I flip this to be vertical, that would fail. It fails the horizontal line test on the original function. So I can't use quadrant 2. That's why it's restricted to stop here. Because if I kept going, I would start getting repeated values. But I could go backward from here, and this is not the same because these are negative values, right? What quadrant would that represent if I go backward from 0? So I can go forward to pi halves. What happens if I go backward? What quadrant am I in? I'm in quadrant 4. So that little piece this is representing quadrant 4. But notice it's labeled as negative pi halves, not as 3 pi halves, because I went backward to get there, right? So I'm going to label that as negative pi halves. So graphically, this is the restricted portion of the sine curve that we use to get the inverse sine. So when I do that, when I flip the x's and y's, this is what it looks like. And you can kind of see I drew kind of some dotted lines showing the wave would continue. It's just the wave vertically, okay? But we're only looking at this restricted portion. Okay, so in the original sine function, the domain was negative pi halves to positive pi halves. And those points are included, so we use brackets because sine does exist here and here, right? There's a sine value of 1, and then here it's negative 1. Okay, so the range, the lowest point was the negative 1, and the highest was 1. And again, those are included. Now, inverse switches x and y. So what was my range, y values, becomes my domain. So now my domain for the inverse is negative 1 to 1. And the range is the negative pi halves to pi halves. If you remember, if we are solving sine of x, the input, is the angle measure. But when we're solving inverse sine of x, our output is going to be the angle measure. That's why range becomes the angle measures. Okay? So because angles and arcs given on the unit circle have equivalent radian measures, inverse sine is also called arc sine. Okay, so inverse sine, arc sine, those mean the same thing. Okay, so this shows down here how that is written as an equation. So inverse is written with the little negative 1 power. Okay, so this is read inverse sine of x. And this is read arc sine of x. And they mean the exact same thing. They both mean at what angle, okay, what is the angle? And it's got to be between here and here because that's the domain, or that's the range, okay, of the inverse. So between negative pi halves and pi halves, what's the angle where sine is x, whatever this x input value is? So when you have a question like this, your answers are always going to come from two quadrants for inverse sine. So looking back up here at this picture I drew, what two quadrants, if we go from negative pi halves to positive pi halves, what two quadrants is that? 1 and 4. 1 is, what is sine in quadrant 1, positive or negative? So the positive in quadrant 1 and sine is negative in quadrant 4. This over here is no man's land. You're not going to have any answers come from over here for inverse sine or arc sine. Only going to come from quadrant 1 or quadrant 4, depending if the value, the input, like this 0.5 in this example, is positive or negative. So quadrant 1 and quadrant 4, bless you. This is if sine is a positive, and this is if it's a negative. So let's try one. Bless you. Arc sine of -1/2. So the negative tells me what quadrant is my answer going to come from? 1 or 4? Quadrant 4. Okay, so I'm going to think about quadrant 4. You don't have to draw and show work. I'm just doing this to teach you what we're thinking. What should be, you should be picturing in your head. You should be picturing quadrant 4 and asking yourself, at what angle is sine 1/2 in this quadrant? Okay, or -1/2. But the 1/2 reference angle, if you remember your reference angles, just going to do quadrant 1 reference angles real quick refresher. If you have your unit circle, it would be helpful to have this out. Okay, so at pi/6 or 30 degrees, got √3/2 1/2. At pi/4 or 45 degrees, we've got √2/2, √2/2. And at pi/3 or 60 degrees, you've got 1/2 √3/2. When you're thinking about your unit circle, what does sine correspond to, the x or the y? Yeah, sine is the y value. So the y value is 1/2 at the smallest angle. That's the 30-degree reference or the pi/6 reference angle. But we know we need to be in quadrant 4. So we need to be at that same size angle, but in this direction. So what does that make it? -30 or -pi/6. I'll give the answer in both radians and degrees. Now, if you're looking at your unit circle, when you see that as not 7, sorry. This point right here, this angle is going to be 11 pi/6, but 11 pi/6 is not the answer. We have to use the negative pi/6 because it has to be between negative pi halves and pi halves. 11 pi/6, if I wanted to get to 11 pi/6, I would have had to go through what I call no man's land over here, right? We can't go through those two quadrants. Quadrants 2 and 3 are out. We can't even travel through them. Does that make sense? So I can't give 11 pi/6 as an answer. It's not in this range. Does that make sense to everybody? So we have to give it as negative 11 pi/6. All right, let's try another one. All right, inverse sine of √3/2. So first of all, this is a positive value. So what quadrant are we going to be getting our solution from? Okay, so we should look in quadrant 1 because this is a positive. And we know our answers are only going to come from quadrants 1 or 4. So it's going to come from quadrant 1. At which angle is the sine value root 3 over 2? I just reviewed that with you right here. Where is the sine value? That's the y, root 3 over 2. Yeah, that's at the 60, or in radians, what is that? What's that angle in radians? Pi thirds. So our answer here is pi thirds, or 60 degrees. Okay, it's the angle up here. All right, what about arc sine of 2? So at what angle is sine's value 2? Any ideas? Thoughts? This is the input, right? This number here in place of x, that's our input for inverse or arc sine. And what does this number have to be between? What did we say the domain for arc sine is? That's the range. Let's go back and look. For arc sine, the range is negative pi halves to pi halves. That's our answer, our angle measure. But what about the domain? What about that input value? What does it have to be between? -1 and 1. Is 2 in that domain? No, it is not between -1 and 1. Okay, so that's not in the domain. So that means there is no solution. Or you may write that as D in E means does not exist. Good? All right. Let's look at cosine. Cosine wave is very similar. It's the sine, it's the same, it's a sinusoid. It's just shifted over from sine, right? But when I think about where cosine is positive and negative, okay, so 0, pi halves, pi, 3 pi halves. Okay, cosine is positive in quadrant 1 and quadrant 4, right? So I can't use both of those. I'm definitely going to use quadrant 1. Okay, so this represents, this piece right here represents quadrant 1. But then I can't go backward and use quadrant 4 like I did for sine, because those would be repeated values. Y'all see that? How they're both positive? They're both above the x-axis. So I'm not going to use quadrant 4 for cosine. If I continue going forward, I get negative cosine values here in quadrant 2. Here, cosine's negative here. So for cosine, I actually can use quadrant 1 and 2. I can go from 0 to pi. Now, if I try to go past pi, these are going to be repeated values from quadrant 2. So I can't use 3 or 4 for inverse cosine. That's no man's land for inverse cosine. Okay, so for inverse cosine, arc cosine, oh, right here. For inverse cosine, those mean the same thing. We're going to use these two quadrants, quadrants 1 and 2. This is what the restricted portion of the parent function looks like. So that is from 0 to pi. And we're including those because cosine exists at both 0 and pi. And the range is the same because it's the same sinusoid. The high and low are still -1 to 1. For the inverse, if I take those x and y values and I flip them, this is the graph that I get. Okay, I switch the x and y, so the domain is now the -1 to 1. So that's the input. of the inverse trig, and the output needs to be between 0 and pi. With me still? So 0 to pi, we said correlates to what two quadrants? 1 and 2. So quadrant 1 and quadrant 2. Quadrant 1 when it's a positive, quadrant 2 when it's a negative. So quadrants 1 and 2 for inverse cosine. I'm just going to highlight up here. I didn't highlight it. Get it for sine. Inverse sine is quadrants 1 and 4. Okay. All right, so let's try this same process. We're asking ourselves, arc cosine of root 2 over 2. So that means we're saying at what angle is cosine's value root 2 over 2? But it has to be an angle between 0 and pi. It has to come from quadrant 1 or 2. So if you need the visual, sketch the visual. Okay, is this a positive or a negative value here? So I know that we're coming from quadrant 1. So look in quadrant 1 of your unit circle. Where is the cosine value? Cosine corresponds to what? The x value of the ordered pairs. We said up here when we were reviewing those angles, we said sine was the y, cosine is the x. So at which of these angles is cosine root 2 over 2? Yeah, that's the 45, or in radians. What is that in radians? Good. So pi fourths or 45 degrees. You're in degrees. Okay, what about this one? Inverse cosine of -1. This means at what angle is cosine's value -1? Cosine's the x, right? So where on the unit circle is the x value -1? Where around the unit circle is the coordinate where the x is -1? Right here, yeah, it's on the axis. This point is -1, 0. That's the angle. What's that angle? Somebody said it. Pi. Or that's 180 degrees if you're in degrees. All right. So if you're starting to see a pattern here, referring back to your unit circle, you may want to find that in your notes, wherever you keep your stuff. You might want to get that unit circle back out to help you with this section. Questions about sine or cosine so far? Inverse sine, inverse cosine? Okay. We're going to check out tangent. Tangent is sine divided by cosine, right? It was the graph that when we graphed it, it had the vertical asymptotes here everywhere that cosine was 0, because tangent didn't exist where cosine was 0. But it crossed, it had the same zeros as sine. When sine was 0, tangent was 0. So it increases left to right between the asymptotes, and then it kept repeating, right? So again, if I flipped this and I had all of those repeated pieces, it would fail the vertical line test. So I have to restrict it to just between two asymptotes. So we're going to restrict it to the middle piece here, which is -pi12 to pi12 again. So that's the same as the sine restriction, except does the tangent function exist at pi12 and -pi12? No. So how do I indicate that we don't include those? parentheses instead of brackets. Very good. The range is not -1 to 1 like it is for the sine and cosine functions. What's the range for the tangent function? How low to how high does this go? Yeah, I'm just going to use the all real number symbol, but it's -infinity to +infinity. It goes forever in both directions. So for the inverse, when I switch x and y, domain and range switch. So the domain becomes all real numbers. It goes left and right forever. And the range is the -π12 to π12 with parentheses. This is inverse tangent or arctangent. Okay, so if you're between -π12 and π12, what two quadrants are we in again? If we're staying between -π12 and π12, 1 and 4, same as for sine. Okay, so I'm going to fill that in down here. This is going to be restricted. Our solutions when we're doing inverse tangent or arctangent, our answers are only going to come from quadrants 1 and 4. 1 when it's a positive tangent value, and 4 when it's a negative tangent value. Now, it's important to make sure we understand it does not include the -π12 or the π12. Tangent doesn't exist at those. That's why there's asymptotes on the graph. Okay? So we're going from -π12 to π12, but we're not including them. All right, so let's try inverse tangent, or excuse me, arctangent of 0. Actually, I didn't sketch the angle, the quadrants like I did for the others. So I'm going to sketch this here. Just as a reminder, we go -π12 to π12. We go in the positive direction to π12 and the negative direction to -π12. But I'm going to have parentheses. I'm not including those. Okay, and the no man's land is over here again. Okay. All right, now let's try this. So where, at what angle is tangent's value 0? If you did your unit circle with us when we did that back in, I don't remember if that was unit 2 or the beginning of unit 3, when we did the unit circle, I had a place for tangent on there. You should have all the tangent values written on your unit circle. No, it's not asking where it's undefined. It's asking where it's 0. So where's the tangent value 0? At what angle? Remember, tangent is sine divided by cosine. So when sine is 0, tangent will be 0, right? Because 0 divided by anything is 0. So if you didn't write tangent on your unit circle, look for where sine is 0. The y value, where's the y value 0? On your unit circle. Yeah, here and here. However, we only give solutions between -π12 to +π12. This over here is no man's land, so I'm not going to give that as an answer, even though that is tangent is 0 there, but I'm only going to give the solution within this restricted section. So my only solution here is 0. Okay, inverse tangent of -1. So we're looking for where's the tangent value -1? Well, it's negative, so what quadrant are we going to be in? Our answers are only coming from quadrant 1 or quadrant 4. If it's negative, our answers are going to come from quadrant 4. So we're looking in quadrant 4. Remember, this is no man's land over here for inverse tangent. So where, at what angle is tangent -1? If you look at your unit circle, it's going to say what? What's this angle labeled on the unit circle? Okay, in radians. So it's labeled as 7 pi4, but that would mean you had to go through no man's land to get there, which you cannot do. So we do not use 7 pi4 as the answer. I need to get there in the negative direction. So what is that? What's the coterminal, the negative coterminal angle there? Negative pi4. Or in degrees, what is that? Negative 45 degrees. If you have forgotten your trig values around the unit circle, remember you can go back those resources, those different links I have in It's Learning, and practice your unit circle again, refresh on that, do flashcards, the online flashcards, different things to help refresh your memory, or just keep studying your unit circle to refresh your memory. Okay. So here is a summary of everything that we talked about today. All side by side. Okay, so I can't remember. I think I used pink for sine. I'll keep it. So inverse sine, you have to be, your solutions have to be between negative pi halves and pi halves. Okay, so if you want to draw the little sketch here, that's here to here. This is no man's land. Okay. For inverse cosine, okay, your answers are going to come from 0 to pi. That's here to here. This is your no man's land. And for inverse tangent, they're going to come from negative pi halves to pi halves, similar to sine, but you're not going to include the negative pi halves and the pi halves, right? You'll kind of get the idea of this. Does that make sense? All right, we are going to stop there. We're not going to talk about the composition yet. Monday, remember, I'm out for a tournament. You're going to have a practice assignment over inverse trig. You'll use these notes. I'll post this video so you can go back and listen to things in the video if you need to. But you're going to do the practice on Monday in class over inverse trig. And then when I come back, we'll finish up these notes.
It's like I might be able to come back for tutorials and just do